Hi guys, Mr. Bay. Today I'm going to go over F3, calculate amounts of reactants for products in chemical reactions. Before we do a couple on the actual IXL, I want to go over how to do a couple by hand first, and then we'll go to the IXL version afterwards, okay? So from here, guys, the question is saying that there's 3 molecules of carbon monoxide, and that reacts with 3 molecules of chlorine in order to produce some amount of phosgene, and you have to figure out how many atoms there are and how many molecules of phosgene there are total. Okay, so I'm going to move on to the next slide here. If you say there's 3 molecules of carbon dioxide, that means you're going to write carbon monoxide 3 times. So CO, CO, CO. Okay. Then over here it says there's 3 molecules of chlorine. So that means you're going to have to write chlorine 3 times. So Cl2, Cl2, and then Cl2. Okay. If you look here with carbon monoxide, there are a total of 3 carbon atoms. So you're going to write 3 carbon atoms for C. If you count the O's, 1, 2, 3, there's a total of 3 oxygen atoms there. And for Cl2, guys, the molecule of Cl2, remember each one has a 2 subscript next to it, which means each chlorine is actually 2 chlorines. So 2, 4, 6, which means there's a total of 6 chlorine atoms. So we've got 3, 3, and 6 total. Okay, go back to the previous slide. Number of atoms of carbon in this reaction is 3. Number of atoms of oxygen in this example is 3. Number of atoms of chlorine in the example is 6. Okay, and remember, guys, to figure out how many molecules of phosgene there are, we go back to our previous slide just really briefly. Divide the number of atoms by number of atoms in the chemical formula. Okay, so for carbon, we'll pick on carbon for now. So for carbon, okay, for carbon, there are a total of 3 atoms of carbon that we have total. In the actual chemical formula, you only need 1 because it has no subscript other than 1 is hidden. So 3 divided by 1 is equal to 3, which means that you have a total of 3 molecules of phosgene that you can make with all these atoms here. Okay. All right. Now going on to the harder one. This one will be a bit trickier, which is the reason why I want to go over this with you guys. So 4 molecules of sulfur trioxide with 2 molecules of oxygen gas, and we'll go over why this is a little bit tricky in just a second. Okay. So we go to the next slide here. If you have 4 molecules of S sulfur dioxide, that means you're going to have to write this 4 times. So SO2, SO2, SO2. Okay. Over here, you have 2 molecules of oxygen gas, which means you're going to have to write oxygen twice. So O2 and O2. Okay. Now, oh, sorry. I was supposed to write sulfur dioxide 4 times. There we go. All right. So if you count the S's, 1, 2, 3, 4. So there's 4 S's there. Okay. Count the oxygens, 2, 4, 6, 8. So on sulfur dioxide, there's 8 there. Okay. And then over here, for every molecule of oxygen, there's 2 atoms of oxygen bonded, so 2, 2 gives you a total of 4. Okay. Now the slightly tricky part that you need to remember, guys, is this. Okay. You have oxygen here, you have oxygen there. Since you have similar, exact same oxygen on both of these molecules, you're gonna have to add these atoms of oxygen together, which means that for oxygen, you actually have a total of 12. Okay, so be aware if you have oxygens on one molecule and have oxygen on another molecule, you have to add those things together. Okay, now going back to the previous slide here, if you happen to have oxygen, we said what? We have a total of 12 atoms, so we're going to write 12 there. And for sulfur, we said we had 4, so we're going to write 4 there. Okay, and in terms of how many molecules of sulfur trioxide we can make, once again, you take the atoms of sulfur you have, which is 4, divided by the number of atoms you need to make the sulfur trioxide, which is just 1. So 4 divided by 1 is equal to 4. So your answer to that question would be how many molecules you can make a total of 4. Okay, so hopefully you guys got that part there.